Hey, quick status update on this Z80 project. Um, Last night I spent a little while soldering some parts onto the back of this board. I got the 5-volt boost to work, soldered in the other chips, and then all of the caps and resistors and so on. Um, I'm still waiting for a few parts from DigiKey. They're supposed to show up tomorrow. That's my 3.3 volt supply for the ESP01, and also a multiplexer to choose whether the wireless connection or the serial port connection is going to talk to the AT Mega. So that multiplexer sits here right now. I've just got it bypassed by basically hardwiring, the A inputs to the outputs so that the receive and send signals from the AT Mega go to this FIDI chip. So that's my hardwired multiplexer there with a couple of wires. So I built this up last night, tried to program this FIDI chip because I have to set up one of the outputs to monitor the V-bus signal. And when I did that and I tried to program it, no dice, did not get any response from the programming software. So I kind of stared at the board for a few minutes and discovered that this one little resistor up here, it's a little 27 ohm resistor, hadn't gotten put on the board. Imagine that. So that's just one little resistor. A lot of these things are kind of optional, but that one's actually a bus termination conditioner. So it's sitting in series with one of the serial lines between the USB port and the 231. So without that, no serial communication. So I soldered that chip in, hooked this up to the laptop, ran the FIDI software, and came right up that time. So I was able to program the C outputs and inputs to do my LED monitoring and check the bus sense. And then when I hooked it up again to PuTTY, I was able to communicate with the command line interface. So had all that working, could go through the basic commands and so on and so forth, but without CPU or memory. So then I went ahead and soldered the Z80 and the static RAM onto the board. And repeated the experiment, and this time when I tried to do anything with the Z80, I was getting timeout errors. So timeout error is when the AT processor tries 1,000 times to tick the Z80's clock and observe a memory request. And if after 1,000 ticks it hasn't gotten a memory request, something is wrong and it screams timeout. So that indicated something was wrong somewhere, but everything else, seemed to be working basically. So I scratched my head a little, getting ready to call it a night, and then suddenly thought, hey, I never really looked very closely at that AT Mega chip after I soldered it up. So threw that under the scope as kind of a last minute thought, and sure enough, right here, there's a solder bridge between two pins, and those pins are involved in letting the AT processor take over the data bus and put information onto it, or read the information out. And what I was observing in stimulating this thing and measuring voltages was the address bus seemed to be working fine. If I triggered an interrupt, the address bus went to the right location. It was incrementing from one M1 cycle to the next, but the data bus values looked weird, and so I had a theory that was probably the problem, and so soldered it up with some, gooped it up with some flux tonight, and soldered away that bridge, and suddenly it works great. So that did seem to be the problem, and so now I can go ahead and run serial software and talk to the command line interface. So there's all of my possible instructions. I can say, look at exam location 0, and I can deposit, whatever I want. And now if I examine my memory, I can see the values I just wrote. I can dump memory and, see those 55, 67, 89 that I just put in there and so on. So that's all working great. And if I go to examine location 0, I can put in a bunch of no-ops and then a jump instruction and a few more no-ops. And there's my memory right now. So if I go back to 0 and I start ticking my clock, let me turn on my bus signals. So there's a no-op at location 1 4 ticks, there's a no op at location 2, 4 ticks, there's a no op at location 3, and so on. And then at location 5, it fetches the jump to location 0 instruction. So it fetched the C3, you can see that on the data bus. And then the bus goes quiet for a little while. That memory request, I believe, was a refresh signal. And now we see another memory request with a read bit. So that's reading the first byte of the destination address. That goes away, and then there's a read of the second byte. And that goes away, and now we're about to go into a M1 instruction fetch back at location 0. So, you know, if we step by whole instructions, you can see exactly what this is doing. And that's doing, you know, perfectly the right thing. So this seems to be working well. We've got, you know, communication between the Z80 and the static RAM. We've got control through the command line interface and so on. So that's all looking good. Once the other parts show up from DigiKey, I'll do some voltage readings here for the ESP01, which will go in right here, and pop in the multiplexer, make sure that's switching, add the power switch for the Wi-Fi up here, and then we should be able to communicate with this either through Wi-Fi or through the USB port. One other problem going on right now, though, is when I try to work with the static RAM. So if I try to write a page of memory into the static RAM, I get these flash errors, and this tells me that it's not successfully erasing the memory. And if I try to read from one of these pages, it'll read just zeros instead of FFs, which is what it should be reading. So if I read in page 0, and then dump the first few locations, they're all zeros. So it's reading zeros from the flash memory, and it's not able to write anything. So something is wrong with this flash chip right here. Now this chip, you know, even though I made the footprint wide enough, I thought, for this particular device, it wasn't. And I had to actually push the legs in to get them to solder. So I went back and looked at that. And aside from this, you know, big blob over here on the left, because I was doing this late at night, when I look at this, these are pretty spotty connections right here between this foot and that pad, and that foot and that pad. So I went in and cleaned those up. Fluxed it up and put down a bunch of solder and got some pretty nice, clean, solid connections here that should be, you know, high enough integrity to work, but it's still not working. So I don't know what's up with that. I gotta go and I gotta take some voltage readings. I'm getting 3.3 volts off of the FIDI 231 chip, and that's only 50 milliamps, but that should be enough to power the flash memory. So I don't know what exactly is going on with that, but I gotta debug that next, and then tomorrow hopefully, you know, these parts will show up, and once I'm done grading final exams tomorrow or Thursday, I will start soldering in these final components and get that working. Once that's all set, I'll put in the connector for the LiPo battery, and then I'll populate the switches, LEDs, push buttons, and so on. Put it in a box, and we'll be good to go. So that's the current status. Thanks.